Today, we're exploring a fascinating new study that reveals your brain has a built-in isolation mode. When you're sick, it's not just fatigue making you want to stay in bed. Your brain actively pushes you to withdraw from social contact. Actively pushes you. Researchers at MIT's Pickauer Institute have uncovered the exact pathway in the brain that drives this behavior. What they found was an immune molecule called interleukin-1 beta, or IL-1 beta, that binds to the receptors in a region called the dorsal raphe nucleus, or the DRN. This binding triggers a circuit connecting the DRN to the lateral septum, which actively reduces social motivation. In other words, social withdrawal isn't a side effect from feeling ill, it's a neural response designed to protect you from others. Makes sense. Interestingly, blocking the circuit in mice stopped them from withdrawing socially. This tells us the brain separates social withdrawal from lethargy, showing it's a deliberate behavior, not just feeling sluggish. Lead researcher Gloria Choi from MIT and Jun Hun from Harvard explained that this mechanism likely evolved to protect others from infections while letting the sick individual rest and recover. It's a perfect example of how the immune system reshapes behavior. Reshapes your behavior. So, the immune brain link, or the IL-B beta, activates DRN neutrons to suppress social behavior. Specific circuit, the DRN to the lateral septum, drives full social withdrawal, not just fatigue. Lethargy unaffected when circuit is blocked. To find this pathway, scientists injected 21 different cytokines into mice brains. Only IL-1B triggered the full social withdrawal response. And using optogenetics, they confirmed that activating DRN neurons projecting to the lateral septum was enough to cause the behavior. Even when exposed to real pathogens like salmonella, this circuit explained the observed social withdrawal. This demonstrates a causal link. The immune system doesn't just signal sickness, it actively orchestrates behavioral changes. Our findings show social isolation after immune challenge is self-imposed and driven by active neural process rather than a consequence of feeling sick, said Choi. So, next time you feel the urge to cancel plans when you're sick, remember your brain is doing its job protecting others from you and helping you to recover. And researchers are just beginning to explore whether other sickness behaviors like appetite loss or mood changes are controlled by similar circuits. So, do IL-1R1 neurons influence other sickness behaviors? Does serotonin play a role in social withdrawal? Could understanding the circuit improve treatment for social or mental disorders? Well, we'll find that out. That's it for today's deep dive into your brain's built-in isolation mode. But stay tuned to Euronurse News for more neuroscience updates and expert insights. Hey, coming up tomorrow on Euronurse, we're diving into the future of prostate cancer care with a powerful look at the newest treatments every urology nurse needs to know. Hey, and this gets 1 CE too. From breakthrough targeted therapies to game-changing imaging innovations, we're unpacking the advances that are reshaping patient care right now. So be sure to watch Euronurse.com tomorrow. I'm Vic Senese. Thanks for watching Euronurse News. And don't forget to like and subscribe. And see you next week for more stories.
The halls with updates and cheer. Trusted insights throughout the year.